Hi, my name is Richard, and in this video, I'm going to demonstrate how AWS creates a network load balancer, or NLB, for a Kubernetes service of type load balancer. This is one example of how to enable external access to web services deployed to a Boomi molecule on EKS. To enable the integration between EKS cluster and AWS to create the load balancer, you need to deploy an AWS load balancer controller in your EKS cluster. AWS provide detailed instructions on how to deploy their AWS load balancer controller if you do not have one already provisioned for your cluster. They currently recommend using version 2.4.7 or later for the controller, which is what I'm using for this example. You should review this document if required. To create a load balancer that uses IP targets, which is the recommended, we added the following annotations to a service manifest and deployed the service. Here we can see my example service of type load balancer, which includes the AWS annotations to create an external load balancer. Using IP targets, this means the load balancer will use my pod IP addresses as the target group. And we want it to be internet facing, which means that AWS will create the required load balancer in public subnets. Note that we are mapping the external port 80 to our molecule default web service port 9090. And this is for HTTP traffic only. There are other annotations supported by the AWS Load Balancer controller documented on their GitHub page. After we deploy the service, Kubernetes will create it and populate the external IP details with the AWS Load Balancer name. You can describe the service to ensure the events show the service was successfully reconciled, meaning AWS has started to create the load balancer for it. If you do not see successfully reconciled, then something has gone wrong with the AWS load balancer deployment, and you should review any error messages. If it shows only the ensuring load balancer message and never moves on, check you have the AWS load balancer controller correctly deployed. Creating an AWS load balancer can take a few minutes, but once it's successfully deployed, you should see it with a status of active in your AWS account. Once the load balancer is active, we can see that it has been created to forward traffic to a targeting group. The target group should show that we have 3 healthy targets and lists the registered targets below. These target IP addresses should match our pod's internal addresses within our cluster. Now we can use a Linux command such as curl to test our load balancer and ensure we can reach the molecule web service. The simplest place to start is by checking we can reach the admin status endpoint and confirm we are getting a 200 response. Now I've confirmed the AWS load balancer is working, I can move on to deploy and test other web services on my molecule. I have a simple web service deployed that returns some properties about the process and environment. Using this process, we can verify that it did indeed run on our molecule. And on node 1 in the molecule. Refreshing the page a few times, we can confirm that the molecule node changes. Confirming our load balancer is working. Hopefully this example will help you in configuring an AWS network load balancer for a Kubernetes service to access your own Boomi molecule web services. Thank you for watching.